everybody. Thank you very much for taking the time to listen to me today. My name's Erika Wilson. I'm one of the managing directors at Wilson Power Solutions. We're a company based in Leeds. And really, what I'm here to share with you today, well, firstly, we'll just have a little look at the agenda. I'll just explain a bit more about Wilson Power Solutions and what we do. And really the main thing of today is all about transformer losses. Just to give you a little thought to take away with you about your own infrastructure. So we'll talk about energy savings just outside the box. And the main thing that's happened this last year is the new Eco-Design Directive for transformers. And what it actually does, it brings tougher design specs for us, the manufacturer. So I'll explain a bit more about that. And then move on to super low loss amorphous transformers. And I think the most important thing is to look at really case studies of where this technology has benefited some of our customers so far. And then of course questions at the end for anybody. So who are we? I really enjoyed the gentleman before, because obviously family business, it was a great story to listen to. We're also a family company. We're actually managed in the third generation now. So we're in our 69th year of business. And in essence, we're transformer manufacturers, so we supply transformers and switchgear to industry. We also have a part of the business that does refurbished and second-hand equipment as well. And really, as a business, we're pioneers of super low loss amorphous technology. We've brought the Wilson E2 to market. We now have 500 installations around the UK. So, on to the main sort of aspect of it. When people think about energy efficiency, most people start to look at the inside of the building. So whether they look at building management systems, whether you look at insulation or LED lighting or anything like that. But not many people actually realise that the source of power to your site is an area where a large amount of energy is just wasted. Your medium voltage supply transformer is often overlooked completely. That's the sort of visual you've got on it, is that grey box that sits there and nobody ever goes in. It's got a sticker on it saying don't go anywhere near me on high voltage, it's terrifying. So why bother looking at it? You leave it alone, you let your maintenance specialist look after it. But that's your medium voltage supply transformer. And typically around 11,000 volts, it can come into your site and then transform the voltage down to usable voltages across your site. Now, staggeringly, through transformer losses within that unit and across the EU through transformer losses, 2.5% of all energy generated is wasted through those transformer losses. So it's a little energy guzzler, it sits there like a radiator, just losing that energy. So as a business, quite a while ago now, we actually wanted to do something about it, but it's very difficult to ask a customer to spend more money on a transformer, put a low-loss transformer into your site. Well, no, because the upfront capital cost is more. So we have influenced EU legislation, in essence. And what's happened is the EU Eco-Design Directive was brought around, and the first tier was last July. And what the aim was to prevent the installation of high-loss transformers across the energy network. So what they've actually done is they've got two tiers. So like I say, tier 1 was July last year, and then there's a second tier which asks to reduce the transformer losses further, and that's effective from July 2021. And the actual directive applies to transformers placed in the market or put into service anywhere within the European Union. So it's an extremely broad piece of legislation. But just to put it into perspective, I'll put a table here comparing, you can see there, 1,000 kVA. That's the sort of average transformer size that you might have in your factory. And on the left-hand side it says standard loss. So we used to make transformers pre-2015 with those loss levels. So Tier 1 for July 2015 asks the manufacturer to design transformers and produce that are 20% lower in losses. And then further to that, we have to then by 2021 manufacture a further 26% lower losses. So it really is a massive shift in the transformer industry for all of us. Now, the National Regulating Authority, they don't just say stick to 2015 losses, they're advising where economically justified on a whole life cycle basis. If you can install a transformer with 2020 losses, 2021, beg your pardon, please do so. So if it's viable, if we can make those payback calculations look appealing, then please do that. So, as I mentioned earlier, the Wilson E2, we wanted to do something about this. In 2009, we pioneered this technology, and what we did was we mixed amorphous metal core, the core material of the product, and then we added to the windings just more copper or aluminium depending on how they were wound. And what we managed to do was create the UK's first super low loss amorphous transformer. And the beauty of it, it actually meets 2021 specs. So if you're looking to just go that bit further and save more money for the business, then this is the product to look at. The formatting isn't hot. It was perfect on my laptop before, by the way. I apologise for that. So we talk about amorphous core, but the meaning for the word amorphous, it's actually a Greek word, and it means shapeless. So you can see there in the imagery on the right hand side, that molecular appearance is very random. So during the magnetisation process of the product, because of the random structure, it means that less friction is created during that process. I like to look at things in simple terms. So less friction is created, therefore lower heat and less losses. So that's how we managed to do that with the amorphous core. And you can see there in the infrared imagery on the right, where the amorphous core material is far cooler in appearance than the standard core steel that other manufacturers would use on the left-hand side. Now, the actual manufacturing process of amorphous transformers is quite different. You can see on the left that imagery, that's a standard transformer product, and the core steel is in laminations. The amorphous core on the right takes about 10 sheets to every one single sheet of core steel. So it really is a different manufacturing process, far more delicate. Now, the most interesting part is, for you guys, is the sort of monetary aspect, I think, of it. If you were going to make a decision and you had a new installation to look at, so you're adding a new transformer to your site, if you wanted to compare a standard product to the Wilson E2, you would save over the lifetime, which is quite moderate there at 25 years, because we know transformers out there are 60 years plus, you would save €60,000 just by installing one against the other. So the upfront capital cost difference that you'd actually pay is normally pay back in about 3 years. So it's quite an easy infrastructure decision to make, and you will get the payback in a very short space of time. But we have to also look at total cost of ownership, which nobody seems to think of or talk about. Now I'll just move on to my favourite slide. Just bear with me. So, would you just do me a favour, and those that commute to work in a car, could you please just stand up? So there's quite a high proportion of people that do commute to work in a car. Now, those people that are standing up, if you have a car that's 25 years or older, can you stay standing? Everybody else, could you sit down? Right, as I suspected. So you wouldn't dream of driving to work in a 25 plus car. Maybe at the weekends if you're fortunate enough to have a beautiful Jaguar or something, it was an older one, but other than that, none of us do. This is what I'm talking about. The average age of a distribution transformer is 62, which is a great age, but it doesn't mean that you're being efficient. So you wouldn't dream of actually leaving your transformer there, age 62, just losing heat. So this is what we're talking about. If you had an existing installation here with this transformer. I quite like this transformer, but I'm a bit sad because it's my job. Anyway, this transformer is old. It's probably 50 years old, something like that. So if you have one of those at your site and then you think, well actually, let me think about fast tracking this replacement, because you may well have looked after the transformer and the oil may be in good condition, but the efficiency isn't so good. If you compared that and then changed it for Wilson E2, you would actually save 33,000 kilowatt hours per annum, and it's a huge amount of money to be just wasting. So it's just something to look at. It's €4,000 per annum. That's not the only energy saving technique we wanted to sort of talk about today. So you've got your guaranteed loss savings there. This is a guaranteed value, but also, if anybody's heard of or experienced voltage optimisation or voltage management, some people recoil with that word because it's got particularly bad press on the low voltage products. But if you do have a site survey and you realise that some of your load types would benefit from reducing voltage to them, you could use the transformer for that purpose, because it has a tap changer on it and you could use the tap changer to deliver that reduced voltage to site. So the reason why this is extremely cost effective is apparent, because you've got one plant footprint on this schematic here. You've got your transformer losses reduced, and you also use your tap changer to carry out the voltage optimisation, and you don't have any extra cabling in case some people feel they should put a low voltage optimizer further downstream. You don't need to do that with this. So it is extremely cost effective. And in a case study later you'll see where one of our customers has benefited from both losses and voltage optimisation. Another thing that's come into play is this dynamic voltage optimisation, where your voltage is going up and down quite a lot. We do an on-load tap changer version of the product, so it has a 17-position AVR relay. So you can adjust, well, you set your voltage at commissioning and then it will keep that voltage and maintain it throughout. So, if you are going to be benefiting from the losses in the transformer and the voltage management, you really can save €130,000. Take it straight from your bottom line over 25 years of savings. And for me, with a very quick payback, you're looking at your total cost of ownership, it just is, it makes sense. It really does. I'll just move to an NHS, it was the University Hospital of South Manchester. And what they did was that all-important site survey. So they had a look at the different load profiles and worked out, could they reduce the voltage to site, was it appropriate? And they managed to realise they could reduce the voltage to site by 6.4%. So obviously the losses and voltage reduction meant for them a 6% reduction in electricity. So annual savings, €40,000. And really it's an install and forget solution, because once you've got that capital piece of equipment there, other than taking an oil sample per year, that's it really for maintenance. So it's very low maintenance. Looking here at the situation with Tesco, they had quite a large-scale roll-up programme to do voltage optimisation across the system. And what we explained to them was that the transformer would do the job. In those stores that were supplied at medium voltage, they will put the Wilson E2 in. And then at the low voltage stores that are supplied, which are the little ones on the street side, they would actually fit a low voltage optimizer. So it's not that I'm saying that there's not a place in the market for those products, but not if you have your own transformer. And then this final replacement was McCain's. And they, of course, did the site survey and they reduced the voltage by 7.5%. And across the whole site, it was a 2.6% electricity reduction. Moving that to financial gains, it was €30,000 per year. And actually now they're, of course, looking to the other McCain's sites just to see whether there's any others that can benefit from fast-tracking that replacement. So I hope in the 15 minutes that I've had, I've just given you a bit of food for thought, really. We do have a stand, I can't remember the number, Laura, sorry, 38, so I'll be delighted to either answer any questions now or we'll just have a chat later when you're free. Thank you very much indeed for listening.
Thank you very much, Erika. Again, I think it's fantastic to see such passion in developing a product that has just such an out-of-the-box saving on energy efficiency straight away. Now, next